right, so we're going to read Chapter 9, Lesson 2. It starts on page 320. And after I read each page, you're going to want to pause the video and put your notes down. So each page should have some notes. It should have a picture. And of course, everything that's black or bolded or even highlighted definitely is something that should be included in your notes. So on page 320, starting with Chapter 9, Lesson 2, Metals. My Planet Diary. Recycling metals. You can find metals in many items that you use every day, including cell phones, computers, appliances, and money. In 2006, the supply of metals in the United States was more than 150 million metric tons. 1 metric ton equals 1,000 kilograms. Many of these metals can be recycled. Recycling helps conserve energy and reduces the amount of waste in landfills. Metals. Percentage of U.S. supply that came from recycling. Aluminum, 43%. Copper, 32.3%. Iron and steel, 48%. Nickel, 43%. Zinc, 24.5%. Page 321. What are the properties of metals? It's hard to imagine modern life without metals. The cars and buses you ride are all made of steel, which is mostly iron. Airplanes are covered in aluminum. Copper wires carry electricity to lamps, stereos, and computers. Can you identify the object that contains metal in figure 1 below? Elements can be classified by their properties, including melting temperature, density, hardness, and thermal and electrical conductivity. Metals are elements that are good conductors of electricity, of electric current and heat. They also tend to be shiny and bendable. Like copper wire, for instance. The majority of elements in the periodic table are metals. The metals begin on the left side and extend across the periodic table. Make sure you're pausing to take your notes. I'm going on to page 322. Physical properties. Figure 2 shows some common metal objects. The physical properties of metal include luster, malleability, ductility, and conductivity. A material that has a high luster is shiny and reflective. A malleable material is one that can be hammered and rolled into flat sheets or other shapes. A ductile material is one that can be pulled out or drawn into long wires. Copper is both malleable and ductile. It can be made into thin sheets and drawn into wires. Thermal conductivity is the ability of an object to transfer heat. The ability of an object to carry electric current is called electrical conductivity. Most metals are good thermal conductors and electrical conductors. Metals also generally have lower specific heat. Recall the specific heat is the amount of energy required to raise the temperature of 1 gram of material by 1 Kelvin. This means that only a small amount of thermal energy is required to raise the temperature of a metal. Some metals are magnetic. Iron, cobalt, and nickel are attracted to magnets and can be made into magnets. Most metals are solid at room temperature. Only mercury is a liquid at room temperature. 323. Chemical properties. The ease and speed at which an element combines or reacts with other substances is called its reactivity. Metals usually react by losing electrons or other atoms. Some metals are very reactive. For example, sodium reacts strongly with water. By comparison, gold and platinum do not react easily with other substances. The reactivities of other metals fall somewhere between those of sodium and gold. Iron, for example, reacts slowly with oxygen in the air, forming iron oxide or rust. The iron chain in figure 3 is coated with reddish-brownish rust. The deterioration of the metal due to the chemical reaction in the environment is called corrosion. Page 324. How are metals classified? The metals in the group have similar properties. Properties within a group change gradually as you look across the periodic table. For example, the reactivity of metal tends to decrease from left to right across the table. In the periodic table, metals are classified as alkaline metals, alkaline earth metals, transition metals, metals in mixed groups, and lanthanide and auxiliides. Alkaline metals. The metals of group 1 for lithium and francium are called alkali metals. Those metals are the most reactive metals in the periodic table. Alkali metals are so reactive that they are never found as uncombined elements in nature. They are found only in compounds. Compounds that contain potassium are used in fireworks, such as those in Figure 4. In the laboratory, chemists can isolate alkali metals from their compounds. As pure, uncombined elements, some of the alkali metals are shiny and so soft that you can cut them with a plastic knife. These elements have low densities and melting points. For example, sodium melts at 98 degrees Celsius and has a density of 0.97 grams per centimeter cubed, less than water. Alkaline earth metals. The metals of group 2 are called alkaline earth metals. These metals are harder and denser and melt at higher temperatures than alkali metals. For example, magnesium is a hard metal that melts at 648.8 degrees Celsius. Alkaline earth metals are very reactive, though not as reactive as alkali metals. These metals are also never found uncombined in nature. Calcium is one of the most common alkaline earth metals. Calcium compounds are essential for bone health. Figure 5 shows an X-ray of a healthy bone. Page 325. Transition metals. The elements in group 3 through 12 are called transition metals. The transition metals include iron, copper, nickel, gold, and silver. Most of these metals are hard and shiny solids. However, mercury is a liquid at room temperature. Except for mercury, the transition metals often have high melting points and high densities. They are also good conductors of heat and electric current and are very malleable. As shown in Figure 6, gold is sometimes used to coat an astronaut's visor. Well, that's cool. The transition metals are less reactive than the metals in group 1 and 2. When iron reacts with air, forming rust, it sometimes takes many years to react completely. Moving on to page 326. Metals in mixed groups. Bicycle frames, such as the one in Figure 7, often contain aluminum because it is durable but light. Aluminum in group 13 of the periodic table. Oh, it is in group 13 of the periodic table. Only some of the elements in group 13 through 16 are metals. Other metals in these groups are, that you may be familiar with, are tin and lead. A thin coat of tin protects steel from corrosion in some cans of food. Lead was once used in paint and water pipes. Lead is no longer used for these purposes because it's found to be poisonous. Now, it's mostly commonly used in automobile batteries. Lanthanides and actinides. 2 rows of elements are placed below the main part of the periodic table. The elements in the top row are lanthanides, compounds containing Nd, and lanthanides are used to make laser lights. These lasers are used for surgeries, for cutting metals, and in laser range finders, such as the one shown in Figure 8. The elements below the lanthanides are called actinides. Many of these elements are not found in nature, but are made artificially in laboratories. And finally, we're on page 327, the last page. Transuranide what in the world? Elements. Elements found that are following uranium in the periodic tables are transuranium elements. These elements are made or synthesized with nuclear particles are focused to crash into one another. They are sometimes called synthetic elements. For example, plutonium is synthesized by bombarding nuclei of uranium-238 with nuclei in the nuclear reactor, with neutrons in the nuclear reactor. To make elements with atomic numbers above 95, scientists use devices called particle accelerators that move atomic nuclei at extremely high speed. If these nuclei crash into the nuclei of other elements with enough energy, the particles can combine into a single nucleus. An example of a particular accelerator is shown in Figure 9. In general, the difficulty of synthesizing new elements is increased with the atomic number. So new elements have been synthesized only as more powerful particle accelerators have been built. Elements in the periodic table with atomic numbers greater than 111 do not yet have permanent names or symbols. In the figure, scientists around the world will agree on permanent names. In the future, scientists around the world will agree on permanent names and symbols for these elements. Whew. Well, with that said, that finishes 9.2. Make sure your notes are done. You should have a picture and notes for every page. Include your page numbers on the left side. And then, as we went along, you have your questions for 9.2 also. Go back and check them and make sure you have them all filled in, as well as the I get it, completing the sentence showing that you get what was being said. Thanks. I'll see you later.